Ignition sequence start.
Good morning, and welcome to a view of the International Space Station Flight Control Room at NASA's Johnson Space Center in Houston. These members of the Orbit 2 team of flight controllers are monitoring all of the systems on the station and helping the Expedition 63 crew members work through their schedule of science and maintenance tasks. Commander Chris Cassidy and his crewmates had a little something extra on the agenda this week, another spacewalk, the third of the expedition, which sent 2 astronauts out to the far end of the truss to continue upgrading batteries for the station's power system.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Sandra Jones. This week, astronauts prepared a science experiment for middle school students, and 2 astronauts ventured out the space station hatch to perform a spacewalk to replace batteries on the orbiting laboratory. Working at the S6 truss of the station, beyond the reach of the Canadarm2, NASA astronauts Chris Cassidy and Bob Behnken swapped out and installed new batteries for the station. On Thursday, the pair spent their day in the vacuum of space replacing old nickel-hydrogen batteries with more powerful lithium-ion batteries. These battery upgrades will store power from the station's solar arrays for years to come. The spacewalking duo will head back out once more. You can tune in to watch the action yourself. Live coverage starts at 6 a.m. Eastern Tuesday. Not everyone can go to space, but everyone can see the Earth from an astronaut's perspective with the Sally Ride EarthCam program. Through this program, students can remotely control a digital camera mounted on the International Space Station and use it to take photographs of coastlines, mountain ranges, and other interesting features and phenomena. The EarthCam team posts the students' images on the internet, where the public and participating classrooms can view Earth from the unique vantage point of the space station. On Monday, Station Commander Chris Cassidy helped middle school students do just that by preparing the EarthCam payload for an imaging session. During a recent orbit over Egypt and the Nile River, NASA astronaut Doug Hurley snapped this breathtaking photo of the area. It prompted Shubham to ask this week's Ask NASA question. He wants to know if the Great Pyramids can be seen from space. The Great Pyramids are in fact able to be seen from low Earth orbit aboard the International Space Station and have been captured in images by astronauts living and working 250 miles above the Earth in the past. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
We're counting down to 20 continuous years of humans on the International Space Station. Follow along at nasa.gov.
The spacewalks that Cassidy and Behnken are doing lately begin in the same way that all other International Space Station spacewalks do, with the lengthy process of getting into the spacesuits that support the astronauts as they float in the vacuum of space. Want to see what that looks like? Well, here's an accelerated view of the process from this past October when European Space Agency astronaut Luca Parmitano helped NASA's Drew Morgan and Christina Cook get ready for their spacewalk. American astronauts and Russian cosmonauts have been flying together on the International Space Station for almost 20 years now. But NASA's first joint space flight with a crew of Russians took place 45 years ago this week. The Apollo-Soyuz test project, the final flight of an Apollo spacecraft, proved that international cooperation in space was possible and set the model for joint operations that continues today on the International Space Station. The International Space Station is a laboratory in space where scientists can remove the constant of gravity from an equation in ways they can't do on Earth. It's a handy trick to have when you're working in natural sciences. For example, researchers are working to learn how surface tension and capillary flow can be harnessed in systems where they move fluids in microgravity, as in moving propellants in a fuel tank during space travel. The lack of gravity in the International Space Station laboratories is useful for experiments involving water and for those involving soil. There's an experiment that's studying sediments of quartz and clay and focusing on the forces between particles that cluster together. The laboratories of the International Space Station provide a home for dozens of experiments at a time in a wide range of scientific disciplines. But the outside of the station also supports scientific research. There's a big experiment out on the starboard truss that was recently put back into service after a series of spacewalks, getting it back to work searching for cosmic particles, which originated billions of light years away and which may hold the key to the origin and composition of the universe.
Humans have observed many wonders across the cosmos. Yet much of our universe is still shrouded in mystery. Among those mysteries is the formation of our universe, which should have resulted in a balance of matter and its corresponding counterpart, antimatter. Much of that matter is thought to exist in the form of dark matter, which can't be directly observed. Much of the antimatter can't be found at all. Studying fundamental particles originating from sources up to billions of light years away may hold the key to understanding both the composition and history of our universe. Welcome to the world of particle physics, currently being explored from low Earth orbit by the Alpha Magnetic Spectrometer, or AMSO2, installed on the International Space Station, or ISS. Planets, stars, interstellar gas, dust. What we're able to observe across the universe comprises less than 5% of the total content found throughout the universe. The other 95% is dark. Dark matter as well as dark energy. Dark matter doesn't interact with or produce light as far as we know. It doesn't consist of normal matter, or matter that can be observed directly. So how do you improve understanding of something that can't be observed? One way is to look for evidence of its interactions. Kurt Costello, the ISS program chief scientist at Johnson Space Center, explains how the giant magnet of AMSO2 is working to help scientists test and modify their theories. Scientists are using AMSO2 to look at cosmic rays, charged particles that travel near the speed of light. AMSO2 categorizes each cosmic ray, looking at a high energy range to see whether that stellar phenomena that we can measure can account for all of the cosmic rays we're seeing. But if you see something in the spectra that doesn't fit, then this could be evidence of dark matter interactions. By studying cosmic rays, scientists are also able to search for antimatter. The Big Bang theory of the universe's origin requires a 50-50 ratio of matter to antimatter. But to date, the amount of antimatter found doesn't come close to matching the amount of matter known to exist. Costello says one of the goals of the mission is to detect antimatter and see if there are any large collections of it out there somewhere. When particles pass through the strong magnetic field produced by AMSO2, their paths bend. Antimatter particles stand out because their paths bend in the opposite direction compared to matter particles. The instrument searches for antimatter with a sensitivity 3 orders of magnitude greater than the original AMS, which flew in space in June of 1998 aboard the Space Shuttle Discovery. This could support the discovery of antimatter pools that were previously undetectable. A key factor in our ability to get the most out of AMSO2 is time. Originally expected to have a lifespan of 3 years, the instrument has continued to perform into its 8th year of operation aboard the orbiting laboratory. In late 2019 and early 2020, astronauts conducted a series of spacewalks to replace AMSO2's cooling pumps, which were failing. Extending the life of the instrument will provide scientists more time in their quest to unveil some of the universe's greatest mysteries. For more on scientific studies being done on and from the space station, go to www.nasa.gov/ISS-science. For more information about the origins of the universe, visit science.nasa.gov.
This mission is Chris Cassidy's 3rd visit to the International Space Station, his first assignment as commander. And despite having already spent 182 days in space, most of it on board this station, Cassidy expected that he would savor every minute of this flight.
The space station is much bigger than people think. You know, when you tell people that I'm going to go live in space, they're picturing this tiny thing where you've got to turn your shoulders, excuse me, to pass each other in the hallway like a cramped submarine. But it's big. And you can spend a whole day and never see a crewmate except for maybe a meal. The other thing people don't realize, it's a machine, just like your car or your house or your air conditioner. It's gonna break, and stuff does. It's just the nature of machinery. Because people sometimes, what, it broke? What do you mean NASA has a thing that's broken in space? Well, yeah, it's a machine, it's gonna break. And that's what we need to do, is keep it running. At the end of the day, there's several things in a mission that requires a person to turn a wrench and fix it. On my first mission, I was a shuttle crew member and we were helping construct the space station. My second mission as a space station crew member, we were just kind of getting up on step on really pushing the science systems of the space station and getting the most out of all of the assets that the space station has to give for science and research. Now I think we are just humming along with the science and research. The greater community and particularly the specialists in Building 30 and Mission Control really know how to run the space station and keep it going well so that we can devote tons of astronaut hours to science. That anniversary is kind of special to me in the sense that Bill Shepard was the commander of Expedition 1, United States Navy SEAL, and I will be the commander of Expedition 63, 20 years later, a United States Navy SEAL. So there's been three of us, Shep, myself, and now Johnny Kim, who have come from the SEAL community to be astronauts, and I think it's really pretty cool that there's the bookends of the 20 years of station will be commanded by Shep and myself. What am I looking forward to most on this mission? This is my third one, and I am going into it with the mindset of I'm going to cherish every single day that I'm there, because it might be the last days that I get to look out the cupola window and see Earth. So I'm really looking forward to appreciating every one of those days. I'll be happy to get back to Earth, to be with my family, but I'm really looking forward to valuing each of those days while I'm there. I'm astronaut Chris Cassidy. Thanks for being part of Expedition 63.
International Space Station crew members who spend many, many months in space, like Chris Cassidy has, have the opportunity to see changes on the Earth below them over time. One of Cassidy's previous crewmates, who has a full year in space to his credit, says he has noticed the human influence on the planet we all call home.
Okay, 3, 2, 1. Well, I've been lucky enough to spend exactly one leap year on the space station, 366 days. So you can imagine that in 366 days, you get to see the Earth quite a bit. Even though we are so busy on the space station, we do try to look outside and glimpse what's flying below us any chance we get. Was a part of me, the dreamer, the little kid that started dreaming about this whole experience now basically 40 years ago. That part of me was still there, unchanged for 30 or 40 years, and just marveling incredulously at the beauty of it all. And I would see clouds and green and rivers, and it would just completely fill my eyes. The difference in observing the world or the universe from inside the space station, looking through the windows, or being outside, is what I describe as the same level of interaction that you can have looking at a beautiful aquarium from the safety of a room. When you're outside and all you have is a helmet and maybe 1.5 inch of plexiglass in front of your eyes, you can see details and colors and shades, the level of detail that you can capture, and the way you experience that universe is going to be very, very different. You want and you feel that you have become part of it, and you can develop that sense of belonging. I think that the first impact of the first flight was that I did see and I did sense how fragile, how small the Earth is. We are used to think of the Earth as something so vast and big, and we don't think that what we do, our daily life, can affect such a vast system. But from space, you get a sense that every individual, every living organism is somehow connected. Seeing the city lights at night, where a place like Europe or the United States or Asia, densely populated, everything is so interconnected, and all those lights and all those lives are apparent. They are right in front of you all together, and you think that all we are doing somehow as an effect on everybody else. You come back from an experience like that thinking that that's what's happening, and then you can see the effects, both the positive ones but mostly the negative ones, in a second flight. And I think you have to acknowledge and grow an awareness, and with that awareness comes the desire to share the experience and share that awareness. It's understanding that the science that's telling us how we are changing and influencing the world has solid mathematical and solid mathematical base. And then you see the effects of it and you just interiorize it. You make it your own experience. And I think that that's what happened. That's why astronauts develop that awareness of and the desire to help the environment somehow, in any way they can.
From 250 miles up, cameras and crew members on the International Space Station have a great view of Earth. It also works in reverse. There are times when almost everybody on this planet has a chance to see humanity's home on orbit from right in their own backyards. Astronaut Nick Hague shares how you can use the Spot the Station website at nasa.gov to find out when the International Space Station may be visible to you.
Did you know that we're traveling at 5 miles a second? We're going around the Earth so fast that we orbit it every 90 minutes. That means on the space station we see 16 sunrises and sunsets each day. Every one is magical to watch. But more important than the view, we depend on the sun's light to power our space station, and we use massive solar arrays to soak it up. Those arrays are so large that when the sun's light glints off them, it's possible to see us from the ground. That means you can look up in the sky at dawn or dusk and see our spaceship flying overhead. So take a few minutes to step outside, spot the station, wave hello to us, and remember what we represent. People from across the globe committed to working together to improve life for everyone on Earth.
The effort to put Americans into deep space, starting with returning astronauts to the moon in just a few years, is making progress all across the country. Take a look at some of the recent milestones as the Artemis program gets the Orion spacecraft, the Space Launch System rocket, and the Exploration Ground Systems infrastructure all in place for the next giant leap. Want to get another look at any of these stories we just showed you? Check us out on YouTube and Facebook. There are the addresses. Make sure you look around because there's lots of cool stuff you can find about NASA and America's human spaceflight program. And if you're interested in good conversation about human spaceflight and space exploration, check out Houston, We Have a Podcast. It's where we talk to folks about their work in all aspects of space exploration. New episodes post every Friday. Today, Gary Jordan gets into the details of the next NASA mission to Mars, the Perseverance rover, targeted to launch in just a few weeks. Go to nasa.gov/podcasts for this week's episode. You will also find all of our previous episodes in the same spot, as well as the full library of all the NASA podcasts. You can find them all on Apple Podcasts, Google Podcasts, and SoundCloud, too.